I said to you right at the very start that integration is just the opposite of differentiation. So in the same way that I could start with 3, I could subtract 2, and I get to 1, okay? So in other words, if I'm moving left to right, okay? If I wanted to reverse that, so in other words, if I wanted to start at 1, okay, wanted to do something to that 1 to get back to 3, what would I have to do? Add 2, okay? So in other words, what you could say, let me write it around the other way, okay? In other words, what I could say is that addition and subtraction are inverses of each other. They undo each other, okay? I could also say the same with division and multiplication, okay? I could also say the same with powers and rooting things, okay? In the same way, differentiation and integration are reverse of each other. They undo each other. So let's think about that in a little bit more detail. Let me just clear some space, okay? So in the same way, differentiation, integration, they undo each other. Just remind me, if I give you some function, okay, and if I differentiate it to get to the derivative function, do you remember it's a two-step process, okay? So if I give you like y equals x squared, for example, what would the derivative be?
2x.
Yeah, y equals 2x. What have I done? What have I done to differentiate?
Multiply the power by the coefficient.
Absolutely. So I multiply by the power. Okay, so that's step 1. What's step 2?
Let's subtract 1 from the power.
Perfect. Subtract power by 1.
I think in integration I add 1 then divide it over the power.
Absolutely right. So you subtract 1 from power. Okay, so that's differentiation. So this is differentiation, d by dx. Okay. So you're right, because integration and differentiation are reverse of each other, they undo each other, it must mean that I want to start here and go back to here, in the same way up here. So if I want to start from 3 and get to 1, I could subtract 2. If I want to go back the other way, I start at 1 and end up at 3 by adding 2. So I just need to undo my process. Instead of going this way, I need to go the other way. This is my integration. Okay, this is integration. Okay, so what's the first thing that I need to do?
Add 1 to the power.
Perfect. I need to undo the subtracting 1. So I need to add 1 to the power. Okay, and then if I want to do, so what's the opposite of multiplying by the power? Undo that bit next. Yeah, good. I then need to divide by the power. Does that make sense? Okay, so let's see this in action. We've got x squared plus 4. Okay, so I've got y equals x squared plus 4. So if I want to work this thing out, if I want to work out what the area is between negative 2 and 3 of x squared plus 4, given some change in x, okay, how would I do this?
X times 3 divided by 3.
Perfect. So first of all, I need to add 1 to the power to get x to the power of 3, and then divide by that power. That's the next thing I need to do. So I'm dividing by 3. Okay. Then I deal with the 4. Well, what is the power of x at the moment?
0 and then 1.
X to the power of 0. So therefore, I need to add 1 to the power and then divide by that new power. Okay.
Basically 4x.
Exactly. It's just basically 4x. You happy with that? Okay. Now there is something else that I need to add here. Okay. Because if you think about it, there could also be some constant. It could be 0 there.
Yeah.
And that 0 came from differentiating a constant, like came from differentiating 3, came from differentiating negative 100. So I just say there could be some constant of integration hanging around at the end there. Does that make sense? Yeah, think about it. Because if I differentiated this number, like if I differentiated 5, what would I get?
0.
0. So I've got to take that into account. Does that make sense?